Hello, this is Raj.
Good evening, Raj. I'm Jerry Hyatt.
Okay.
Nice to meet you.
All right, pleased to be back. Last time I spoke, it was at UOP.
Okay.
Last time I addressed you guys.
Well, hopefully we'll be back there soon.
Yeah, yep. Just a second. Let's see. Participants. All right, here we go. Dennis, how are you?
I'm good.
Good evening, Dennis. Got something coming in overhead, do you?
This is the way it looks. I got the camera right there, so I'm looking at the television screen up there, which looks like that.
Hey, I know that guy.
I wonder why.
That's a more suitable background for this talk, given the nature of this talk.
So how long ago were you here?
Oh, at least 2 years, I think.
Okay.
It's probably 2019 when I gave that talk. Okay. I remember Tim, Jeff, maybe even you, some of the other board members that treated me. We all went to Red Robin for dinner.
Okay. I usually can't get away to the dinners because I work at UOP and I have labs Thursday night right up until 7. And so I usually miss the dinners. And also 2019, I had heart surgery. So
okay.
What do you remember what time of year it was?
That I don't. It might have been October-ish, but I can't be sure.
Oh, okay.
It was a good time. It was fun.
Stockton Astronomical Society meeting. I'm Mike Laverie, your current president, who you're trying to ouster, but I know better. Other than that, it's fine. I guess everybody's healthy and doing well, right? No complaints?
Hi.
Hi. Okay. So we might as well just start off with our speaker. We have a wonderful one tonight. Tim's going to introduce him. And this should be fun. And then we have some business, a few things to talk about. So Tim, go ahead.
Okay.
Yeah.
I'm going to share my screen with you and go through these announcement slides. So somebody give me a heads up when you can see my screen.
All right, there it is.
Yeah.
Got it.
Yeah.
Very good. Okay, so a little 3-month look ahead for our programs. In June, Rebecca Lewis, our own newsletter editor, is going to be talking to us, continuing the theme of galaxies, but the study of the Milky Way galactic center. So Rebecca, we're looking forward to that.
Yeah.
In June. July 8th at our regular meeting, and these will all be virtual Zoom meetings, so continuing to meet virtually.
Okay.
July 8th will be with Don Mockholtz. And Don, I saw you join the meeting tonight, so welcome. His topic is comet hunting. He's the resident expert on comet hunting, so you don't want to miss that program. It'll surely be pretty interesting. And then in August, Pranavera Hyseni is talking to us about the astronomy program in Kosovo. So we go international in August. So those are the upcoming programs. And I know Fred Schumacher has other programs beyond August that he's planning. So looking forward to a lot of good upcoming SAS programs. May 26th, many of you have probably heard about the total lunar eclipse. You see there, it starts at 1:47 a.m. This is, I believe, a Wednesday morning. So middle of the week, but one of the few, if not the only lunar eclipse, I believe, this year. Somebody correct me if I'm wrong, that we can see from the West Coast.
Well, it is a Wednesday morning.
Yep. Totality is short. It starts at 4:11 a.m. and then it's a setting moon, so it's setting over in the southwest, right about sunrise. So we'll be competing with the low horizon and a sunrise and a moonset all at the same time. So we are thinking about making this kind of a club event where maybe we find a location to gather and to view it, someplace that has a nice southwest horizon. Not sure what that location is yet. We're open to suggestions. The idea being maybe we could meet out there, observe the lunar eclipse as a gathering, and then maybe go to an early breakfast together at some nearby restaurant, or maybe something still get us to work on time. So anybody interested in that, just by a show of hands or by your comments, I'd be interested if there's any interest in meeting up for that lunar eclipse on the 26th.
I would be interested.
If I were closer, I'd love to go, but I'll probably just settle for my neighborhood.
Okay.
The fields around me.
Okay. Anybody else? Okay. Well, maybe stay tuned to the chat in the bulletin board, and if we come up with something, we'll distribute our plans. So Jerry, this is your slide that you want to announce.
Yeah, the Silicon Valley Astronomy Lecture Series always has a good presentation. I went to one a couple weeks ago that I enjoyed on the first stars. Someone is tracking down the first light from old stars. Anyway, this is the latest talk that is coming up. So it's a talk, along the line of SETI. So they'll be looking for what kind of signals would we be looking for when we're looking for extraterrestrial life. It's a free event, and I have the complete information is given in the chat room. There's a link in the chat that'll give you the complete information, but here's all you need to actually get there is this YouTube site. Go to there on the time and date, which is the same day as the lunar eclipse, just in the evening. And you can get there and take a look. Next.
Good. Okay, thank you, Jerry.
You bet.
Next is a little bit of a discussion with you folks, if you will. As you know, University of the Pacific, our regular meeting location, has not yet opened up. We don't know yet when that's going to be. And we're thinking about ways to get together in person that will get us together as soon as possible without waiting for UOP to open their doors and welcome us back. So the idea was maybe we could just get together for a simple potluck. Well, we normally have at least one a year, usually at a star party, but this one's going to be sometime early this summer, maybe mid to late June or so when the weather's nice, maybe at a local park, at one of the county parks, maybe Oak Grove. We're totally open to what suggestions or what people might want to do. And this is just a social gathering suggested to get us all back together and see each other in person again. And not so much a star party or viewing party, because most of these parks are going to require that we leave by dusk. So maybe a late afternoon, early evening, just kind of thing where you bring out your lawn chairs and a plate to share, and we all gab it up and see each other and enjoy each other's company and all that goes along with that. So Doug and I were just talking about maybe finding a location at one of the parks. He's checking in with the county. I'm sure we can find some place that will suit our needs. It's very casual. But what we really wanted to do this evening was get a little bit of a poll from you folks. Maybe if you just raise your hand, if you're interested in coming. In general, we're seeing if there's any interest, and then we'll go about planning and sharing up the updates. So if you're interested, please just raise your hand in front of your screen there, and we'll other board members take a look, and we'll get an idea.
Yeah.
Mike or Jeff, are you raising your hands? There you go.
Rebecca's raising her hand.
Okay. You don't have to
I'm on the phone, so I'm not going to raise my hand, but I am raising my hand right now.
Okay.
You just can't see it. But a suggestion would be Valley Brew is opening up again, but not that I'm into beer or anything, but support our Oak Grove site.
Right.
And I've been seeing parties there.
Good. Thanks for the suggestion. Okay. It looks like it's fairly well accepted, or a lot of folks are interested. So, well, thank you. We'll kind of make some plans then and get back to you. And we'll set a date and a location. So be planning what kind of dish you're going to cook up and surprise us all with. Okay, I have just a brief little quiz for you all to see how observant you are. So these are 4 observatories, and first of all, I ask you not to mention the names out loud. These are 4 observatories. They're all in California. And we're going to do this quite simply. It's the honor system, either on a notepad next to you or mentally jot it down in your mind. If you recognize and can name any of these 4 observatories, jot them down on a notepad. It's the honor system. And here in just a moment, I'll share with you the answers. But look at them closely. And as I give you a moment to think and ponder those photos, I'm going to give you some hints as well. So the photos at the top, 1 and 2, are Southern California observatories.
Really?
Okay.
Wow.
That's right. The 2 on the bottom, number 3 and 4, are Northern California observatories. So these are all 4 California observatories. I think number 1, that most of you will get that one, is I think the background there is a dead giveaway. But just another hint, that observatory is used in many films or movies as a set. I most know it as one of the settings for the James Dean movie Rebel Without a Cause. The number 2 photograph there is another Southern California observatory. It's, I think, most noted for one of the most famous discoveries by Edwin Hubble. And then number 3 there is an observatory not too far from us here in Stockton in the Northern California area. And you may all be surprised to know that we actually have a member of our club that is an employee of this observatory. And then the one on the right with the 2 domes is another Northern California observatory. I'll give you a hint. It's over in the Bay Area. And it is actually a space and science center, more or less a public observatory and education center, if you will. So, well, with that, hopefully I gave you enough hints. You got it written down. Let me share with you the names of those observatories. Number 1 is the Griffith Observatory in Los Angeles. I think that's pretty well known. Mount Wilson Observatory is where Edwin Hubble discovered the expansion of the universe on the 100-inch Hooker telescope. The Lick Observatory is another old observatory on Mount Hamilton, just south of us and just west of San Jose, or Fremont, more accurately. And our own member, Tom Palmer, has recently landed a job there. So maybe we'll get Tom to share with us sometime in the future what he's doing at the Lick Observatory. And then naturally, the Chabot Observatory in Oakland serves as a public science center. And we've had some great speakers that are part of that program from Chabot. So let me ask you now, who got all four right?
Him and Amelia did, plus we've been to two others.
Excellent, excellent. Jeff, you got all four right?
Yeah, I've been to all four and got them right.
Excellent.
I got all four after the clues.
Okay.
Because I thought Mount Wilson was actually Mount Palomar. That's what I guessed at first. Then when you said Hubble made his discovery there, I realized it was Mount Wilson.
Okay.
So I kind of cheated.
Good. Who else got four? Who got three? Two?
I got three.
Okay. Oh, very good. Well, I apologize for putting you through this. I don't have any prizes for you. Maybe Jeff will have one, but hopefully you enjoyed that for a moment of.
I'm so good, I got 7.
Did you? Well, that's because you're a math teacher. You must have done some of that new math there, Jeff.
You got it.
Well, without further ado, as they say, let me share with you the introduction for our speaker tonight. My slides will move here. Raj Dixit from the Sacramento Valley Astronomy Society. I'm proud to announce is our speaker this evening. Raj has been an amateur astronomer since he was a kid, and his father first introduced him to the hobby through a home-built 6-inch Newtonian on a manual equatorial mount. So I bet that was fun to learn on, Raj. Raj is currently the vice president of the Sacramento Valley Astronomical Society, and he enjoys doing public outreach, schools and other public star parties, as well as presentations and lectures on various topics. He's observed every planet, including Pluto, which he still considers a planet. Good for you, Raj. And the entire Messier catalog, the Herschel 400, and he's 200 plus objects into the Herschel 400 Part 2 list. So quite an undertaking there, Raj, that you're on. When not looking through his 16-inch Orion Dobsonian, his 120 millimeter applet refractor, or his humble 90 millimeter Orion refractor, he works as an attorney for the state of California. So we won't hold that against you at all, Raj. Since July 2020, you've been working on the COVID contact tracing for Santa Clara County. And so we appreciate your service in that capacity, Raj. And we welcome you to the Stockton Astronomical Society's May program. And I'll turn it over to you at this time.
Thank you very much. Thank you for that warm welcome. Thank you for having me back. I think the last time was probably a couple of years ago. It was at UOP when I gave a talk on the difference between the Hubble Space Telescope and your telescope. So I'm very happy to be back addressing Stockton Astro Society. And just be warned, the cost of attending this free lecture is, it's not financial, it's more psychological, because you are going to have to be forced to endure my awful, atrocious, wretched sense of humor, which will manifest itself going forward. So anyway, I'm going to start sharing my screen if that's okay.
I'll let you know when we can see it. It's coming through. There we go.
Okay.
You can see it now, Raj.
Slideshow from the beginning. All right, so here we are. That you may recognize is the Hubble Deep Field image of a multitude of galaxies in what was thought to be an empty patch of space. I will be discussing each one of these individually, so I hope you're ready for a long night. So, it's galaxy season, and it's time to go hunting galaxies. So many of you may recall this image from your younger days, from childhood. Be very, very quiet. I'm hunting galaxies. Okay, it can only get better from that. So what are we talking about when we talk about galaxies? Galaxies are composed of stars and dust and, as far as we can tell, dark matter, all bound together by gravity. They have to compose at least a few million stars to be considered a galaxy. Generally, 10 million solar masses appears to be the accepted minimum. The word galaxy comes from the Greek gala for milk, galaxias kykelos, milky circle. In Greek mythology, Zeus brought his son Hercules, or Heracles is the authentic pronunciation, home for his wife Hera to breastfeed while she was sleeping. Now, Hera didn't like Heracles because Heracles was half mortal, the result of one of Zeus's numerous affairs. When Hera woke up, she pushed Heracles away, which caused some of her milk to spill into the night sky. And that's why we call it the Milky Way. And it was the Romans who coined, galaxy came from milk, and then Milky Way came from the Romans, who called what they saw in the sky the Via Lactea, the Milky Way. Now, in the early 1900s, many astronomers believed that the entire universe was within our own Milky Way galaxy, that everything we saw, including those other strange spiral shapes there were so many of in the sky, they're just star clusters within the Milky Way galaxy. Now, others, such as Harlow Shapley, or is it Shapley? I've heard it both ways, a scientist and the head of the Harvard College Observatory, argued that those spiral-shaped blobs, which is just thought to be dust and gas, said no, they're separate. They're island universes. Island universes was the term. And it wasn't until 1924 when Edwin Hubble identified several special pulsating stars called Cepheid variables inside the Andromeda Galaxy, or as they called it back then, the Great Spiral Nebula in Andromeda. And he realized by calculating these must be outside the Milky Way. These are 1 million light years away at least, and in fact, they're almost 2.5 million light years away. These island universes are unique collections of stars well beyond the Milky Way. So this is our home galaxy. It's a barred spiral. You are here. The Milky Way has at least 100 billion and probably closer to 400 billion stars. It's at least 100,000 light years across, and some estimates that include the outer reaches of the halo place it at almost 200,000 light years across. It's about 1,000 light years thick on average, and at its thickest, about 2,000 light years thick. Very recently, recent calculations have put it at 129,000 light years across and 1.5 trillion solar masses in weight. The uncertainty comes from the mystery of dark matter and whether or not the materials between the Milky Way and the Magellanic Clouds, the two small galaxies that orbit our galaxy, should they properly be considered part of the Milky Way or not? Now, from the sun to the center of the Milky Way is between 25 to 28,000 light years. It takes 240 million years for the sun to complete one orbit around the galaxy, and the galaxy as a whole rotates between 220 to 360 million years. They're not quite sure yet. That's the window. And the central bar of the Milky Way rotates every 100 to 120 million years. So the next is a crude map. This gives you a rough idea of what we're dealing with. Here's the sun, the galactic North Pole. The disk of the galaxy is here. There's a halo of what's believed to be dark matter. About 150 globular clusters, which are conglomerations of about several hundred thousand stars each. Some of the oldest stars in the universe. Every large galaxy is accompanied by its own group of globular clusters. So The next, this is the Milky Way as we see it. This is a photo taken from the Grand Tetons in Wyoming. Now, how can we know the shape of the Milky Way is a spiral since we're inside of it? The clues we have to the shape of the Milky Way are as follows. When you look toward the galactic center with your eyes, and that would be down here in this photo, you see a long, thin strip full of gas and dust and glowing stars. And this suggests that you're seeing a disk edge on rather than an elliptical or globular shape. And we can also detect, especially when you go south of the equator, the bulge at the center. And since we see spiral galaxies that have the same form, as we'll see in subsequent images, it's a bit of a tip-off. Second of all, when we measure the velocities of stars and gas in the Milky Way, we see that overall there's a rotational motion. It's not random. That's another characteristic of a spiral galaxy. Also, the fractions of gases, the colors of stars, and the dust content of the Milky Way are similar to that seen in other spirals. And as far as the Milky Way's bar, the observed light distribution coming from the 2-micron all-sky survey shows a left-right asymmetry in brightness and the vertical height. That's explained by the near end of the bar to us being located on that side. And the observed gas velocities wouldn't be possible, apparently, in a galaxy in a spiral that had no bar. So based on the velocity of the gas, the conclusion is that the Milky Way is a barred spiral. So this galaxy here is UGC 12158. That's a Hubble Space Telescope image. It's in the constellation Pegasus. And this is believed to be almost a spitting image of the Milky Way. So if we could go outside the Milky Way and look back on it, we'd see something akin to this. At least that's according to the best estimates of current astronomers. Now, why is spring galaxy season? The brightest stars and clusters and nebula, which you see in the winter sky, the bright star Sirius, the Orion Nebula, a lot of the Auriga open clusters, because in the wintertime, the orientation of the Earth is facing toward the Milky Way's arms itself, even more so in the summer when the Earth is rotated to face the center of the galaxy. And thus you see the brightness of the Milky Way going down towards Scorpius, going down towards Sagittarius. In the summertime, the globular clusters and open clusters and dark nebula inherent along the Milky Way. Now in the spring and the fall, and especially in the springtime, we are right about here, the night side of Earth is pointing out away from the center of the Milky Way. It's pointing out more or less toward the extragalactic void. And so the great empty reaches of space out there, there's nothing to see but galaxies because there are no clusters of nebula. Now, there are, of course, objects in the Milky Way that we can see in spring and fall, but it's during spring and fall, and especially spring, that we have the most unobstructed view out of our Milky Way, and when we can see the most galaxies outside the Milky Way. And galaxies are so remote that a lot of them are difficult to see even with a big telescope. In the spring, we see Virgo, Canis Venatici, the hunting dogs, Coma Berenices, which is Berenice's hare, Ursa Major, the great bear, all chock full of galaxies. They have clusters, even superclusters of galaxies. In the fall, you get a lot of galaxies in Perseus, in Pegasus, Aquarius, Cetus. But spring is absolute prime time for galaxies. And the galaxies that I mentioned, they're all looking away from the plane of the Milky Way, which is reflected in this glowing area. And it's not as if there are no galaxies looking toward the plane of the Milky Way, looking toward its center. It's just that the Milky Way itself is blocking our view of them. So now we're going to run down the types of galaxies. Barred spirals, like the Milky Way, although this example is the bar is more prominent than our own Milky Ways. There are regular spiral galaxies. There are irregular galaxies. There are lenticular galaxies. Oops. Okay. Peculiar galaxies. And elliptical galaxies. Now, the more detailed, as we talk about spirals, spirals can be barred or they can be unbarred, and they vary by the tightness of the spiral arms. And it was Hubble who first introduced this system, but the modern system was by French-American astronomer Gerard de Vaucouleurs. SA galaxies have significant bulges and tightly wrapped, smooth spiral arms. SAB galaxies are similar, but they have more obvious resolution on the arms. SB, there's more resolution and more open arms, and so forth. There's always a natural progression within each type. SC galaxies, the bulge tends to be rather small, and the arms are patchy and open. Excuse me, I'm going to try to move this toolbar a little bit because it is interfering slightly. Okay, there we go. So as you can tell, it proceeds by the tightness of the spiral arms and the presence or not of a bar. The Milky Way, by the way, is considered SB capitals and small bc. So in between these two would fall our own Milky Way galaxy. SBM is for semi-irregular galaxies like the Magellanic Clouds. Spiral galaxies still have gas and dust. They're younger galaxies, not brand new, but they're younger to middle-aged galaxies that are still experiencing star formation. So this is my favorite type of spiral galaxy. They call the quote grand design spiral. This is Messier 101 or M101 in Ursa Major. Grand design spirals have very prominent, well-defined spiral arms, and only 10% of spirals are like this. The technical classification for M101 is SABCD. That's another beautiful galaxy, another favorite, Messier 81, also in Ursa Major, another grand design galaxy. Its classification is SAAB. Now, another type of spiral is called the flocculent or fluffy spiral. About 30% of all galaxies are flocculent spirals. They're patchy and have discontinuous spiral arms. And although the Milky Way isn't a flocculent one, take a look at these dust lanes. And remember the photo of the Milky Way over the Tetons. Notice the similarity. So that's one way you can tell that the Milky Way is itself a spiral galaxy, because what we see in the summer skies, the dark dust lane of our arm of the Milky Way, is what we see in other spiral galaxies. This is M63, the Sunflower Galaxy in Canes Venatici, type SABC. Then, of course, we have the barred spiral. At least 1/3 of spirals are barred, and some estimates place it as high as 2/3. Our own Milky Way is barred, although the bar isn't as prominent. This is NGC 1300 in the constellation Eridanus, so it's a wintertime object. So the next main category after spirals, we have elliptical galaxies. These are older galaxies. Star formation in ellipticals has basically ground to a halt because the gas and dust supplies of the galaxy are nearly depleted. So type E ellipticals, their normal type E's are ellipticals with no structural details. The E plus signifies a late elliptical, which may include faint extended envelopes of large clusters, or is a more of a you can see the transition between these galaxies and transitioning all the way to lenticular. So the late ellipticals are older and have a bit more detail visible. And the zero classification are ellipticals that are almost spherical, and the more drawn out or elliptical or elongated would be a proper term, the higher the number. Okay. So this is galaxy IC 1101, and it probably inspired the phrase "go big or go home." This is the largest galaxy known to astronomy. It's 6 million light years across. Not away, 6 million light years across. And it weighs 100 trillion solar masses. That's the best and most recent estimate. It's a type E0 elliptical. Now, the next type of galaxy after ellipticals are the lenticular type galaxies, designated S0 in the scheme of things. They also have a bright central bulge and an extended disk-like structure. But unlike spirals, the disks of these lenticular galaxies, and lenticular means lens-shaped, they have no visible spiral structure. They're not actively forming significant quantities of stars. This particular lenticular is an impressive telescopic object. It's Messier 102, aka NGC 5866, in the constellation Draco. After lenticulars, the next type of galaxy is the irregular galaxy, like this. An irregular galaxy is one that lacks sufficient structure to form either a spiral or elliptical shape. About a quarter of all galaxies are irregular. Some of them were formerly spirals or formerly ellipticals that were distorted by gravity, coming too close to a larger galaxy. This is NGC 1427A in the constellation Eridanus. After irregulars, the next type is peculiar galaxies. A peculiar galaxy is a galaxy of unusual shape, size, or composition. Between 5 and 10% of all known galaxies have been categorized as peculiar. Astronomers have identified two types of peculiar galaxies: interacting and active galactic nuclei, or AGN. Now this is Centaurus A, also known as NGC 5128 in the constellation Centaurus. The A signifies it's the brightest radio source in that constellation. This galaxy is believed to be the result of a collision between a spiral and an elliptical eons ago. It also has an active galactic nucleus, a compact region at the center that has a much higher luminosity than would be normal. And that luminosity can be invisible light. Doesn't necessarily have to be invisible light. It can be over at least any portion of the electromagnetic spectrum. And the characteristics indicate that the luminosity is not produced solely by stars. Instead of visible light luminosity, often the active galactic nuclei is extremely active in X-rays or other emissions, ultraviolet, gamma ray, that can be stemmed from a supermassive black hole. And many peculiar galaxies were cataloged by Halton Arp, who produced the Atlas of Peculiar Galaxies in 1966. There were 338 galaxies in the Arp Atlas of Peculiar Galaxies. It was published by Caltech. The primary goal of the Arp catalog was to present photographs of the different kinds of peculiar structures found among galaxies. Centaurus A, or NGC 5128, also bears the catalog number ARP 153. This lovely pair is ARP 271. Its constellations NGC 5426 and 5427 in Virgo. It is not known for sure whether or not these two will eventually collide, or they've already had a close encounter and are slowly drifting apart. But it's likely they'll continue to interact for several tens of millions of years, creating new stars as a result of the mutual gravitational attraction between them. And there's a bridge of stars already connecting them. This pair is about 130 million light years away from us, and the total distance across appears to be about 130,000 light years. This pair was originally discovered in 1785 by William Herschel. And part of me likes to think that maybe this is a sneak preview of what's going to happen when the Milky Way and Andromeda collide in a few billion years. All right, this is another active galaxy with an active galactic nucleus. Here, the active nucleus is believed to be the result of the accretion of matter around a supermassive black hole at the center of the galaxy. Now, the Milky Way, like every large galaxy with a bulge, does have a supermassive black hole at the center, but the Milky Way is not an active galactic nucleus galaxy. It's not emitting the abnormal amounts of radiation that an AGN galaxy would. This particular AGN is NGC 7742 in Pegasus, informally known as the fried egg galaxy. So, the Milky Way is part of what we call the local group of galaxies. And the Milky Way is the second largest galaxy in the local group. The local group consists of about 54 galaxies in an area 10 million light years in diameter. The biggest member is the Andromeda Galaxy, M31, and the bronze medal goes to M33, the Triangulum Galaxy, which, as you may have guessed by now, is in the constellation Triangulum. And most of the galaxies in the local group are dwarfs or irregulars. This map gives you an idea of what the local group consists of. Here's another map going out to 16 million light years across, and giving you an idea of here we are. And for the sake of cartography, the Milky Way was placed at the center of the map, even though there's no center to the local group, with M31 slowly moving toward us. That is the Andromeda Galaxy, Messier number 31. A bit bigger than the Milky Way, and as you can see, look at the dust lanes and see how reminiscent they are of what we saw in that photograph from Wyoming. Although it's a bit bigger than the Milky Way, it's remarkably similar in that it has two prominent satellites, just as the Milky Way has the two prominent Magellanic Clouds. We have just above the spiral, M32, and here, M110. And this galaxy, as Tim alluded to in his quiz about the observatories, Edwin Hubble during the 1920s observed the Andromeda Galaxy and used the Andromeda Galaxy to prove that the Milky Way is not the entire universe, that the spiral nebula and Andromeda is in fact its own separate island universe, millions of light years away, far beyond the edge of the Milky Way. And there is Hubble's original, there's a glass plate of Hubble's original find. He was looking at glass plates and found a Cepheid variable. He marked VAR. He found that these Cepheid variables, which are standard candles used to gauge distances, they have an intrinsic brightness that depends upon their period of variability, how long they take to fluctuate in brightness. And when he found them in the Andromeda Galaxy, he was able to use the luminosity to ascertain that the Andromeda Galaxy must be at least 1 million light years away, easily, and probably more than that, and therefore they could not be inside the Milky Way. There's a flagged Cepheid variable, and also the 100-inch telescope at Mount Wilson, called the Hooker telescope, after businessman John D. Hooker, who was contributed a great deal of financing for it. It was the first time that M31 was ever resolved into individual stars. Previous telescopes were not capable of doing that, and it was assumed and Andromeda was assumed to be a star cluster within the confines of the Milky Way. There's a flagged Cepheid variable. That is M33, the Triangulum Galaxy. It's an active galaxy. It's not an active galactic nucleus, but the red hydrogen 2 regions show that it is forming stars at a healthy clip. There's a lot of star birth and star formation happening there. Now, why is there clustering? Why does the local group exist? Why do galaxies tend to cluster together? Best theory that astronomers have to date is that galaxies form into clusters because the gravitational tug on each other, every constituent galaxy tugs on each other, that tends to pull them together, while dark energy tends to separate clusters as a whole from each other. So clusters move apart. The individual constituent galaxies within a cluster often bond closer together. That push me, pull you, the interplay between dark matter and dark energy, clumps galaxies within any given cluster together. The local group is part of what's called the Virgo cluster, and the Virgo cluster itself is part of the Virgo supercluster of between 1,300 to 2,000 galaxies. The Virgo cluster contains between 1,300 to 2,000 galaxies. We're a part of it. We're a part of the Virgo cluster, so is the local group. The Virgo cluster contains, the Virgo cluster is itself part of the Virgo supercluster, which contains 100 galaxy groups. Okay, because around us are not just our own local group. There's the M66 group looking toward Leo, the M81 group looking in that direction, the M101 group, both of those looking toward Ursa Major, the M51 group also looking toward Ursa Major. So the Virgo supercluster is one of about 10 million superclusters in the observable universe. And the Virgo supercluster is part of what's called the Pisces-Cetus supercluster complex, which is a filament of numerous galaxies, all in gravitational, with a common gravitational bond. Now, a 2014 study, this helps indicate what I was just saying, what I was talking about with the Virgo cluster and the Virgo supercluster being extending out a little bit farther than that. But as recently as 2014, there's an indication. Look at the yellow highlight, the yellow indications. The Virgo supercluster itself here appears to only be a lobe of an even greater supercluster called the Laniakea supercluster, and appears to consist of about 100,000 galaxies spanning 520 million light years. And as you can see by this map, there are numerous such superclusters that we know of. And with Hubble having reached near its limit, with James Webb hopefully coming online soon, this number and this map could get larger, and the number of clusters and galaxies could become a whole lot larger. Let's only hope. So there are plenty of galaxies to see, plenty of stuff to hunt down. So that's your mighty galaxy hunter. And a lot of the galaxies we've talked about here, M31, Andromeda, M32, M33, M101, M51, M81 and 82, Centaurus A, many thousands more. They can be seen. This is a 10-inch Dobsonian. All those can be seen in an 8-inch. The numbered Messier ones can be seen in a 3 to 4-inch telescope if you have a good, dark, clear sky. An 8 to 10-inch Dob will show you thousands of galaxies and keep you busy for years. I've seen probably going on 800 galaxies. But the Mighty Hunter raffled this off to a fellow member at our couple of years ago when we had still able to do our star party, our annual giant star party. Because I raffled this off because I acquired my new weapon. That is a 16-inch go-to Orion Dobsonian, a truss Dob, 6'1", 200 pounds, bigger than I am. It's the photo, my profile photo that Tim showed at the beginning. I expect to see a whole lot more galaxies using this. It's estimated there are 1 trillion galaxies in the universe. If I've seen 800, that's 1 trillion minus 800 is 999 billion, 999 million, 999,200. So I should wrap it up by this time next year. And of course, when you spend that much time behind the eyepiece, you'll end up looking like this. And to quote Looney Tunes again, I will be Porky Pig, and I won't do the accent though. That's all, folks.
Okay, excellent, Raj. Excellent. Thank you so much. Wow. A tour of the galaxies. Okay, let's go ahead and
questions, comments, complaints.
Yeah, let's go ahead and
mostly
fire away your
complaints, I'm
questions.
sure. Remember to unmute yourselves.
Yeah, I got it.
Absolutely.
Can you go back to that picture of the peculiar galaxy, the one in Centaurus?
Oh, Centaurus A?
Yep.
Okay, they'll permit me to share my screen again. Let's see.
It's totally fantastic.
Thank you. Thank you. I'm glad you enjoyed it.
Yep, we can see it now, Raj.
Okay, yeah. Ooh. Apologize for the whiplash here.
Yep.
Okay, here we go. There we go. Centaurus A.
Wow.
That's called warp speed, ladies and gentlemen.
That's hot. That's hot.
Those the matter going off to the upper left and lower right, those, would that be considered relativistic jets?
I don't believe so.
AGN?
I have not read that. M87 has a relativistic jet, which is basically gamma and synchrotron radiation emanating from the supermassive black hole. I believe these are just wayward streams of stars that, when the spiral and elliptical hit each other, just got cast out into intergalactic space.
Well, I'm looking at all that light out there. I was thinking that they weren't necessarily stars, but basically photons being given off by stuff that's being hit by high energy.
All right. I'm not aware of any jet in this galaxy. Now I could be wrong, but the only jet that springs to mind right off the top of my head is M87.
Okay. All right. Got a nice streamer of dust off of that left there, doesn't it?
Yep.
Yeah. All right. That's what I was just wondering if that was
okay.
Considered relativistic jets.
Okay. And maybe they are, but I'm not aware of it. And when I read about Rebecca had a question, that was Centaurus A, NGC 5128.
Yeah, Raj, I have a question for you.
Sure.
We often think of interacting galaxies as kind of being destructive. They're crashing into each other, but it seems as if you indicated, confirm this for me, that when galaxies interact, that they could actually be forming new stars as a result of the disturbance in the gas and the new gravity situation there when they interact. Would you care to comment on that?
Yes, that is quite possible, because all that tidal interaction can really shock and stir up gas and dust. I'll share another photo if you don't mind. Not only can it stir up gas and dust, it can actually not be destructive and actually be somewhat aesthetically beneficial. And I'll show that this way. Here's a famous galaxy. This is the Whirlpool galaxy. I hope you all can see it.
We can see it now.
Okay. Very active in star formation. The bigger galaxy is dominating the smaller galaxy, NGC 5195. This beautiful, almost near perfect spiral, I read in recent research, and also I think in Sky and Telescope, is believed the near perfection of this spiral is because of the interaction the gravity of the smaller galaxy passing through it. And there's very active star formation here because this smaller galaxy basically was put through the ringer, but the gravitational pull of the smaller on the bigger one helped organize it, helped pull it into a perfect spiral. It might have been a looser, more disorganized spiral, but with the gravitational tug of this smaller galaxy passing by it, that helped turn the whirlpool to the beautiful, perfect grand design spiral that it is. So it's not necessarily a bad thing. And I'll find one more photo about that though once I can. So it might be easier to do it this way. I'll try this. Okay, and bear with me for a minute. Okay, I'm going to share my screen again. That's Messier 82.
Okay, we can see that.
Okay, the spiral again. This is called the Cigar Galaxy. It's near M81. Again, it may have helped pull M81 to the beautiful spiral that it is, but M82 clearly got the worst of it. But the thing is, it's forming stars at a rate of 5 times faster than your average star-forming galaxy, because the shock of that passing close to the much bigger M81 slammed and caused all the gas and dust in there to hit each other, react, generated heat. It served as a real impetus to star formation, and that's the bright red is indicating in H2 just super active star formation on steroids. So yes, Tim, the interaction of galaxies can be destructive, but it can be productive as well. It can be a great impetus to star formation. And it looks like Rebecca's told us that those are relativistic jets on 5128 indeed. Okay, thank you very much.
Raj or Eric here. Can I trouble you to share once more? Can you go back to that second image of the local group?
Oh, okay.
And then can you remind us of what the size was of that largest known elliptical galaxy?
Okay, we'll go back to, that's the biggest galaxy. 6 million light years across. Again, not 6 million light years away, 6 million light years across, with an estimated solar mass, estimated weight of 100 trillion solar masses.
So yeah, so then if you can go back to the second image of the local group, I was hoping to try to get a size comparison. So that graph is saying that's that second to the large.
So here's the Milky Way, and that's 6 million light years.
Yeah, so it's almost
so that galaxy.
It's almost the entire local group. Yeah.
Yeah, it would go out to there.
Okay, yeah. That's what I was thinking, but I just wanted to confirm. Thank you very much.
Okay. Oh, my pleasure.
And where's that galaxy located again, Raj?
I need to just give me a second because I have it in my notes and then I
it comprises its own group all of itself. Huh?
Yeah. What galaxy? What group does that galaxy belong to? Any group it wants to. Oops.
Okay, is Raj?
It is in. I'll get it for you. It is in Virgo. It is the center of the Abell 2029 cluster.
Okay, very good. Other questions?
And it's about just over 1 billion light years away from us.
Oh, excellent. Very good presentation. Excellent slides and preparation and narration, Raj. Really appreciate it. Let's give Raj another hand, everyone. Thank you very much. And with that, Mike, we'll turn it back over to you.
Okay. Does anyone have anything of importance to speak of tonight? I don't have anything. I think Jeff's going to announce the winner of our lottery, but that's about it.
This is Eric. I would just make one quick comment. I had read that tonight through the 15th is a pretty good time to view Mercury. So if you want to get out in the next couple of days and try and spot it just after sunset, you might want to give that a go. Tonight, we're having the meeting tonight, but it was actually just below and to the right of the moon tonight. But the 15th is supposed to be pretty good as well, from what I hear. So I just thought I'd let everybody know.
Do we get a 1% certificate?
Yeah.
Yeah, we do have a 1% certificate because only 1% of the population ever sees Mercury. So if you do see Mercury, let me know and I'll get you your 1% certificate. We saw it at Pedal Hill the other night. Well, I didn't see it, but Grant saw it. Grant McKinney saw it. I was doing other stuff. I wasn't looking for it.
Very good.
All right. So we do have a winner on our door prize. And that would be Tim Clark. Mike has bought a 1971 Jaguar E-Type with a V12, and it's red.
Okay. Well, I was going to do a 1913 Liberty head nickel, but I decided that you probably aren't any mismatches, so you probably wouldn't like the coin.
Well, I appreciate
Anyway.
the Jaguar, though. Thank you, Mike.
Yeah. Oh, you're welcome. Yeah. In your dreams, right? Yeah. Anyway, I have an announcement to make for what it's worth. 50 years ago, this coming June, which is next month, I graduated from optometry school. So I've been doing this 50 years now, and at the end of the month, I'm retiring. I can't believe it. I found someone to buy my practice.
Congratulations, Mike.
Thank you. So anyway, some of the people were surprised, and some said I'm too early to retire. Others said I should have retired 50 years ago. But the common question I get from everyone is, what are you going to do? And I thought about it, and I think my best answer is, I don't want to work anymore. That's what I want to do. I'm not going to do anything other than do what I want to do. So hopefully I'll be in a better mood and things will work out okay.
Plus, you can go on star parties on Tuesday nights now.
That would be something that would be a lot of fun. Do all-nighters in the middle of the week during the summer. Okay.
Congratulations.
Thank you. Anyway, folks, unless there's something else, I'll call the meeting. We'll adjourn.
Thank you for having me. Thank you all for your warm welcome.
Always appreciate having you.
Thanks, Raj.
If you guys weren't too put off by it, I'd love to come back sometime.
Yeah, nice job.
Absolutely. Yeah.
Bring more galaxies.
Okay, that's right. That's right.
Excellent. We'll see y'all at the next social or at the June meeting when Rebecca Lewis will be presenting. I'm looking forward to that, but hopefully we'll get to see y'all maybe at a potluck or a picnic, something coming up soon.
All right. Take care, everyone.
Thank you.
Adios,
Bye,
everybody.
everyone.
Good night, everyone.
Night.